Singularity is based on the idea that there will be exponential improvement of the chips that support the compute of artificial intelligence systems. And that has been true for a few decades now, according to the Moore's law. And also, it's projected to be true for a few decades ahead from here. So that is a basic assumption behind the scaling hypothesis and the exponential growth of abilities of artificial intelligence systems. And Ray Kurzweil have been popularizing this idea of singularity, which I think was originally conceived by I.J. Good, a colleague of Alan Turing, in the Enigma deciphering project. And but when it comes to physiology in the cell and in the neurons, the same logic doesn't apply. In the cell, there are many, diffusion limited reactions, and you simply cannot scale them up. Uh, it's very limited. It's also an environment of low Reynolds number, so that the momentum of something is rapidly lost. So there's no preservation of information apart from the specificity between chemical reactions, like the specificity between an enzyme and its substrate. These things would be the founding stones of uh, computation, biological computation within a cell, which is totally different from the kind of digital computation that we have in computers, laying the foundation for artificial intelligence systems. So the same logic of scaling cannot be applied to the physiology in the cell. So this poses, I think, a fundamental problem when we try to connect the fruits of the computations of artificial intelligence systems and uh, its biological counterparts. When we try to design the mechanisms, reactions in a cell, so that we can probably cure diseases, fight aging, and so on, we can't actually simply transfer the logic of scaling improvement of the exponential growth of artificial intelligence systems to what's happening in the cell. So there's a gap there. That's a huge gap. So somehow there must be some logic or model or theory to bridge these two gaps, if they are bridged at all. Um, what is more likely to happen is probably that the physical environment that in which the artificial intelligence systems are developed are totally different from um, what's happening in the cell. So these two things might actually be totally different domains of computation. And I think this is something that we really need to take into account when we discuss the applicability of AI to biology.